Good evening, dear students.
Good evening, sir.
Well, before we start this topic, I want to ask a question. Have you heard people say that while we're in the night in Nigeria here, some people are in the day?
Yeah.
Yes, sir.
Can you tell me why that is so? Some people are in the night, and others on the same surface of the earth are in the day. Because of what?
The shape of the earth.
And different places on the earth have things that we use to identify them. When you're talking about graph, you have your x-axis and you have your y-axis. Is that right?
Yes, sir.
The combination of the x and y-axis will enable you to determine a point. The same thing on the surface of the earth. We have a combination of two things that will help us to locate where a place is. For example, in Lagos here, we can say Lagos is on so, and so. And that is going to lead us to the topic, longitude and latitude. To the topic what?
Longitude and latitude.
Before I proceed, on this topic we're going to learn some things. And some of those things we're going to learn are, as you can see, the objectives of this lesson. At the end of the lesson, you should be able to, 1, describe the shape of the earth. 2, explain briefly the rotation and revolution of the earth. I know you talk about this, you think this has to do with geography. But you will find that there are questions, even on mathematics, will involve the rotation of the earth. You say, okay, what would be the distance when the earth rotates on this, so. And that's why you need to know what is rotation before you can answer the question on rotation. I hope I'm communicating.
Yes.
Then we want to define, also you should be able to define what lines of latitude and longitude are. And of course, if I say, okay, I want to move from this place to Abuja, you have to know the distance from here to Abuja measured along the line of latitude. These are things we're going to talk about for today. Can you see how the earth looks like? You've seen an orange before?
Yes.
I know you have. The earth is like a ball, though it's not a perfect sphere. We call it, in geography you call it what? Geoid. Fine. Here we call it a spheroid. If you would see, look at this. Can you see this? This is like the earth. Is that right?
Yes, sir.
Now, look at this, 60 degrees, 45 degrees, 30, 15. The equator, 15 degrees south, 30 degrees. What do we call them? We call them lines of what? Latitude. What do we call them?
Lines of latitude.
And you can see the lines of latitude. This, if there were another one here, they are parallel. Is that right?
Yes.
That's why we call the lines of latitude parallel. We call them parallel lines of latitude or parallel. If you look at it again, you see another one that goes from the top here. We call this place the North Pole, and we call this place the South Pole. These lines, they pass through the North Pole and also the South Pole. But they go just this way and that way. Each of them passing through the North Pole and the South Pole. What do we call those lines? They are lines of longitude. Exactly. The combination of the line of latitude and the line of longitude will determine the position of a place on the Earth's surface. Just as the combination of your x value and your y value will determine the point on your graph. Do you agree with me?
Yes.
And then the equator here is the biggest line of latitude, and it is from there we measure upward, and that's why you see them north, while we also measure downwards, southwards, and that's why you have degrees south there. I hope that is clear. We'll talk more about that as we proceed. You can see that. Look at the shape of the earth. The shape of the earth closely resembles a flattened sphere. A spheroid with an equatorial, the equator is the middle, equatorial radius of 6,378 kilometers, while the distance from the center of the spheroid to each pole, when we say each pole, the North Pole and the South Pole, is 6,357 kilometers. You see that the two of them are not the same thing. That is why we say it is not really a perfect sphere. If it were a perfect sphere, the two radii should be the same. Is that not so? Yes. But for the basis of our calculation in mathematics, we're going to assume that it is a complete sphere. I hope that is clear. And we'll take the radius as 6,378, though approximated to what? 6,400 kilometers. But you don't approximate unless you're told to do so. Now you can see these are parallels of latitude. The equator there, another parallel of latitude. This is to the north, while this is to the south. And of course, what are these? They are lines of longitude. What are they?
Lines of longitude.
I hope that is clear.
Yes.
Now, students often have problems with trying to make calculations on longitude. Look at this diagram here. We're going to also use this to explain. Can you see this line? Yes. This line is moving towards this point here. It is just like this line here. Okay, it's just like this line here. Okay, can you see the line?
Yes, sir.
It is just like this line. Now this is the equator. Is that right?
Yes.
Take this line I'm showing you just as this. If the angle between this and this is theta, let's call it theta. The angle between this line from the center of the earth to that point on that line of latitude, if that angle there is theta, then it means that this line of latitude will be latitude theta degrees north. If it is alpha, it will be latitude theta degree, alpha degrees north. But if it were like this, this would not be south.
Yes.
If this angle now is say 40, then because this is the equator, this will be latitude 40 degrees south. Exactly. I hope I'm communicating.
Yes.
So when we say latitude this, longitude this, you know what we mean. So what are the lines of latitude now? The lines of latitude or parallels are imaginary parallel. Imaginary, what do you mean by imaginary? You just imagine them. It's not as if on the surface of the earth, in the sky, you will see lines. No. They just imagine it to be there. They are parallel because you can see that this and this are parallel to each other. If there's another one like this, it's parallel. Just as if you take an orange and you cut it. You can cut it on top, you can cut it in the middle. It will still give you what? A circle by the time you remove it. They are imaginary parallel horizontal. Latitude are horizontal, but longitude are what? Vertical. Longitude are what? Vertical. Exactly. Imaginary parallel horizontal circular lines. We call them lines, but we want you to know that they are circles. Because in the calculations we are going to do shortly, we are going to involve calculations, and we are going to have calculations involving circles, sectors of a circle. So you have to know that they are not really lines in the sense of lines, they are circular lines drawn around the surface of the earth. The latitude of a point or place on the earth's surface, just as we said here, is the angle between the horizontal line of the equator. Where is the horizontal line of the equator now? You can see that horizontal line here. This line here. It's horizontal. This we always say horizontal, parallel to the ground of the equator. And the line joining the point to the center of the earth. Where is that line we're talking about now? This. The angle between the horizontal line of the equator and the line, this line, joining the point. You want to know the latitude of this point on the earth's surface. The angle between that horizontal line of the equator and this line that joins that point to the center of the earth is the latitude of this. That is, if this angle is 40, then this is latitude 40 degrees north. Is it clear?
Yes.
Join the point to the center of the earth. Can you see that from the diagram there?
Yes.
That is just on the board, but you can visualize it here, the way it is. This is the line of latitude we are talking about. This is the horizontal line of the equator, and this is a line that joins that latitude to this place. The angle between them is what? 41 degrees, and that is what makes that latitude to be 41 degrees north. I think that is clear enough. It is thus the angle between the horizontal line at that point. The horizontal line at this point, we're taking this latitude for example, the horizontal line at this point is just something like this. The angle between that horizontal, look at my palm, my hand the way it is, that horizontal level there. The angle between that horizontal line at that point and the line joining, okay, between this and the line joining this point to the center of the earth. Now, I just said this. I said now the angle between this line and this line is also the latitude. Why is this so? Look, I said, and since this angle and the first angle mentioned are alternate angles. I think you have heard of alternate angles. Alternate angles are Z angles. Is that right?
Yes.
Look at, can you see that this looks like Z?
Yes.
Whatever this angle is, that is also what this is. So if this one is theta, this is also theta. So this angle can also determine this latitude as latitude theta degrees north. I think that is clear.
Yes.
The equator is latitude 0 degrees. This one in the middle is the equator, and it is latitude 0 degrees, and it is the reference point. You know what we mean by reference point? The point from where other things are determined is the reference point. It is the reference point from which other latitudes are measured northward or southward. I think I'm communicating.
Yes.
Latitude 90 degrees south being at the south pole, that's here, the last one, while latitude 90 degrees north is at the north pole. I think that is clear there as regards the latitude.
Yes.
Then what is longitude? As I said, a combination of the latitude and the longitude will determine the position of a place. Lines of longitude or meridians. These are imaginary vertical circular lines drawn across the surface of the earth, passing through the north and the south poles of the earth, and at right angles to the parallel of latitude. Now look at this. This is a line of longitude. Is that right? This is a line of latitude, which is the equator. Can you see that? What's the angle between them? 90. What's the angle here?
90.
So the lines of longitude are at right angles to the lines of latitude. Communicating?
Yes.
Passing through the north and south poles of the earth and at right angles to the parallels of latitude. The longitude of a place is the angular distance of the place measured eastward or westward from the what? I want to keep you in suspense. Have you heard of what you call the Greenwich meridian? Greenwich meridian is just, for the latitude, what's the reference point for latitude? The equator. For the longitude is the reference point, and it is longitude 0 degree. It is what?
Longitude 0 degree.
If the Greenwich is like this, longitude 0, and you have another line of longitude that comes across it like this, passing through the North Pole, you can see there will be an angle between these two palms here.
Yes.
Is that right? If this is my 0, the way you are now, let's say this is longitude 0, the Greenwich meridian. Look at my palm, it is to the right of Greenwich. Is that right?
Yes.
And to the right is what? East. To the left is what?
West.
West. If the angle between the two of them here is theta, then this will be longitude theta degrees east. If we use this as our example here, let's assume this is longitude 0, the way you are looking at it. This is longitude 0, the Greenwich meridian. Look at this line of longitude. This is another line of longitude. Is that right?
Yes.
If the angle here is 40 degrees, then this is longitude 40 degrees east. If the angle here is 20 degrees, this angle is 20. then this will be longitude 20 degrees west. Clear?
Yes, sir.
Let's go on. So between the Greenwich meridian, which is longitude 0 degree, the Greenwich meridian passes through London in where? Britain. And it also passes through Accra. I know you have heard of Ghana.
Yes.
Yes. The Greenwich meridian passes through Accra in Ghana. All other longitudes are measured from 0 degree, can you see, to 180 degrees, both east and west of the Greenwich meridian. When you move from here, if there were a longitude, line of longitude were here, that would be 90 degrees. I hope I'm correct. So 0, 90 degrees east, then to 180 degrees east. Again, 0, 90 degrees west to where? 180 degrees west. You will now notice that the longitude, this same line of longitude 0, is the same one at the back. Can you see?
Yes.
It's the same line at the back that has now formed what? Longitude 180 degrees east or west. The same line that is longitude 180 degrees east is the one that is longitude 180 degrees west. Am I communicating?
Yes.
All other longitudes are measured from the 0 degree to 180 degrees, both east and west of the Greenwich meridian. The line of longitude in conjunction with the line of latitude is used to determine the position of a place. Note that a line of longitude has two opposite values. One in front, while the other is at the back. If you are talking about this one also, this one in front, the other at the back. It is the same line. I think that is clear. If you were to look at it, if this angle is 30, for the same line here, this one will be what? 60. No, 90 plus 30, 120. Because it should be a straight line. Angle on a straight line is what? 180. So if this one is 30, the remaining one here will be 180 minus 30, which is what? 150. So that longitude 30 degrees east is the same line of longitude 150 degrees west. Am I communicating?
Yes.
Yes, sir.
The line of longitude that is 30 degrees in front is the one that is longitude 30 degrees east in front is the one that is longitude 150 degrees west at the back. Clear?
Yes, sir.
So while the other is at the back, each longitude 0 degree is on the same line of longitude, the same great circle as longitude 180 degrees west. Similarly, longitude 30 degrees east and longitude 150 degrees west are on the same line of longitude, one in front while the other is at the back. Longitude 90 degrees east, that's 90 degrees east. Suppose we start like this. 90 degrees east here is also the one that becomes 90 degrees west. And 90 degrees west are the same great circles. I know that will lead us to what is a great circle. Because I said great circles there. We talk about small circles and great circles. What is a small circle? If you watch this, do you notice that the radius of this is smaller than the radius of this?
Yes.
But for these longitudes, all of them seem to have the same radius. Right? And the radius of this longitude is just the same thing as the radius of the Earth, because it passes through the North Pole and the South Pole. That is why we call this line of latitude that does not have the same radius as that of the Earth a small circle. What do we call it?
A small
A small circle is a circle that has a radius that is less than the radius of the Earth. While a great circle is a circle that has the same radius as the radius of the Earth. All lines of longitude are great circles, while the equator is the only line of latitude that is a great circle, because that one also passes through the surface of the Earth around the center. But for the other latitudes, they become smaller and smaller and smaller until they get to 90 degrees north, and of course to 90 degrees south. So for all lines of longitude, they are great circles, while the equator is the only line of latitude that is a great circle. And for a great circle, the radius will be big R, which is the radius of the earth. While for a small circle, its own radius will be small r, because it is smaller than the radius of the earth. You are going to bear this in mind when we now start our calculation. We just have one calculation for today, right? But you see, I want you to get this so that when we start our calculation, whenever the movement is along a great circle, you use your radius as big R. But when the movement is along a small circle, since the radius is smaller, what do you use?
Small r.
R. Distance is measured along parallel. The circumference of any line of latitude, which is a small circle, is given as 2 pi r. You know that?
Yes.
Where r is the radius of the line of latitude. Note that the movement of a body along a line of latitude is either eastward or westward through the latitude, though the latitude itself is either south or north. Now look at this. This line of latitude is north. You know, this is the equator. This is in the north. While if there's another one here, it will be where? In the south. But when something moves from here to here, how has it moved? To the west. When it moves from here to this place, how has it moved? To the east. Movement is to the east or to the west. But the latitude itself is in the north or the south. The same thing in longitude. Because when you see this in questions, you'll be able to understand. The teacher said longitude is south now, or longitude is east or west. Why is this question saying it moves south? No. Look at this line of longitude. Lines of longitude are measured eastward or westward. Is that right? Yeah. But when something moves from here to here, how has it moved? Northward. Is that not so? When it moves from here to here, how has it moved? Southward. So you should know the difference between the movement and the location. Longitude is east or west, but the movement is north or south. While latitude is north or south, but the movement is east or west. Is it clear? Can you see? Now, know that the movement of A says that if two bodies A and B are on the same latitude, so on the same latitude are such that their longitudes are theta 1 degrees east and theta 2 degrees east, respectively, or theta 1 degrees west and theta 2 degrees west, respectively, then the angular distance, let me keep a little in suspense. Here is a line of latitude. Let's assume this is latitude 60 degrees north. Are you following me?
Yes.
This is longitude 30 degrees east. This is longitude, let's take this as the Greenwich meridian. 30 degrees east, 30 degrees west. Or let's even take it as, firstly, let's take it as this is the Greenwich. 0 degrees Greenwich. This on 30 degrees east. This on 60 degrees east. What will be the angle between them? 60 minus 30. Is that right? This Greenwich, which is 0. This is on 30 degrees east. This place, 60 degrees east also. They are both on the east. The angle between them will now be what? Because from here to here is 60. While from here to here is 30. Let's even use 20 to make it easier so that you understand what I'm saying. From here to here is 20. But from here to here is 60. What will from here to here be? 60 minus 20. So, because they are both on the east, to get the angle between them, you must subtract. Similarly, when they are both on the west, to get the angle between them, you must subtract. But when one is on the east and the other is on the west, here is longitude 0 degrees. This is 20 degrees east. This is 40 degrees west. What will be the angle between them? 20 plus 40. Do you agree?
Yes.
That makes 60 degrees. Now, between them is theta. So you subtract when they are on the same side, while you add when they are on opposite sides. However, if the two bodies are opposite latitude, theta 1 and theta 2 degrees west, then the angular distance between them will be theta 1 plus theta 2, just as I explained. Say the length of the whole line of latitude of angle. What's the angle of the circle? 360 degrees. So it means the whole circumference here is 360 degrees. If 360 degrees is for the whole circumference, what will this one between them, which is theta, what will it be? We just use simple mathematical manipulation. 360 degrees equals 2 pi r. Therefore, theta will be theta over 360 times 2 pi r. That was just how they came across that. So, since the length of the whole line of latitude of angle 360 degrees 2 pi r, the length of arc AB of angle theta is theta over 360 times 2 pi r. If the radius of the earth is big R, then of course this will become big R. Then the radius r of the line of latitude theta, which is a small circle, is given as now. If you look at this quickly, this angle here, we want to find the radius of this. The radius from here to here. Are you following me? This is the radius of this line of latitude. Is that right? Yes. But from here to here is the radius of the earth. You understand? Yes. From here to here is the radius of the earth. From here to here is the radius of the line of latitude. That, and this is what? A right angled triangle. The angle here, theta, is the latitude of this. Do you agree? Yes. If the angle here is theta, then this is latitude theta degrees north. This is small r, this is big R. What connects small r and big R in terms of this? This adjacent, and this is what? Hypotenuse. From your ka to r. Which one has adjacent and hypotenuse? Ka. So cos theta is small r over big R. And so small r will be what? Big R cos theta. That is why whenever the movements along a small line of latitude, your 2 pi r becomes 2 pi small r. But since small r is big R cos theta, it becomes 2 pi r cos theta. Because small r is r cos theta, then that formula becomes theta over 360 times 2 pi this small r, which is now what? R cos theta. I think that is clear there. So as we round off there now, let's take this example. It says calculate the distance between 41 degrees north. I'm going to give you an assignment, 1 or 2, and that's the end. After this, does this example, then you have an assignment and we end the class. But before we stop, I will just quickly go over what we've done. Calculate distance between 41 degrees north, 7 degrees west. You see the combination of that now is used to determine the place. You look at this. If this is 20 degrees east, this longitude is 20 degrees east, and this is latitude, let's say 60 degrees north. This point here is somewhere 20 degrees east, 60 degrees north. The combination determines this place. Of course, this place, though it's on the same latitude, but it's not on the same longitude. So you can easily use that to locate different points. So this point now is on 41 degrees north, 7 degrees west, and another one 41 degrees north, 15 degrees east. Rather, what is the distance measured along their line of latitude? Distance between them, and also the radius of the line of latitude. If you look at it, the angle between the 2 points along the latitude, you know they are on different points. What would that be? 7 plus 15 is what? 22. Is that right? Yes. So we have theta is now 22. So 22 over 360 times what? 2 pi. What's the radius of the earth? 640. Cos what is the line of latitude there? 41. Because the second theta there is the line of latitude, while this one is what? The angle between the 2 points. The angle between the 2 points is 7 plus 15 because they are on opposite sides. And so we have 22 over 360 times that. By the time you find your calculation, rather, you get 1853.36. And then you say, what is the radius of the line of latitude? How do you get the radius of the line of latitude? You said r cos theta. R has been given as 6400, and what will cos theta be? Cos 41 to give you that. So you can see that 7 on this side, 15 on this side, the angle between them is 7 plus 15. 7 here, 15 here, you add them together, 22. So I think that is clear there. Your assignment. You can just take this as your assignment. I will talk about that during the next class. God bless you. What have we talked about? The longitude and latitude. We said longitude is what? Longitude or meridian. While latitude is what? Parallel. The combination of the two of them can be used to determine the position of a place. Do you agree?
Yes, sir.
I'm sure with this now you should be able to have solve a simple problem like this. This and this, they are on the same side. So what do you think you're going to do? You subtract. Do you agree with me?
Yes.
God bless you. Thank you very much.